Welcome to He Can Fix Anything. Today I'm going to put this temperature and pressure relief valve in this crusty old water heater. As you can see, this perfectly functional but 30-year-old water heater has seen better days. And the temperature and pressure relief valve has started leaking. You can see as it heats 50 gallons of water, that temperature and pressure relief valve starts seeping and sometimes pops off a little bit, which is not good. And you can see when this was originally installed, it does not have the drain tube connected to it, and so it'll spray across the room, which is very dangerous. And this is something, like I said, it was installed 30 years ago, and since it's still working and working fine, rather than replace the whole water heater, I'm going to just replace this valve. I did something that few people ever do. I actually read the label that comes on these, and there's a couple of important points. The first one is you're supposed to actuate this to work it, to open it and let it close once a year, which I think few people ever do. And obviously it's a little bit risky to do it without that drain pipe on it. The other thing it says that I found very interesting is you're supposed to replace this temperature and pressure valve every 2 to 4 years. Like I said, this water heater has been in here for 30 years, and I have actuated it a few times over the years, more recently, just to make sure it was working. And so I don't know of anybody that actually replaces these until they start failing. And so I think I'm in good company in doing this now. In preparation for this job, I've done a couple of things. First, I turned off the water to the water heater. The second thing I did was open a sink valve, actually the bathtub valve, because that's much lower than the top of this water heater. And that way it will not only drain the pressure, it will drain some of the water down a little bit. And I'm going to leave that valve open because when I open this up, I can either use the actuator, or when I start to unscrew this, there will be a vacuum in this tank. And so that will allow it to drain down a little bit more. And then once it's, that way just don't get some water wasting here on top of it. The other thing I did in preparation, I bought a new temperature and pressure relief valve. I can't say that these are a standard size, but I did verify that this thread size matches up with the top of the water heater. And the other thing I bought is this drain tube. And so this is a straight one, and I'm going to need to bend it 90 degrees on this edge. And so I'll show you how to do that later in the video. Now, one last thing that I forgot, and this is critically important, is you need to shut off the electricity to the water heater. This is not gas, this is electric. And so if it's gas, you need to shut it off. If it's electric, you need to shut it off, because obviously there is a risk of electrocution anytime you have any water out and open. And then also you don't want it turning on and starting to heat the water while it's open. Now that the heating source is turned off, the water is turned off, it's depressurized, I'm going to go ahead and open this valve up just to let the water level drop a little bit inside the tank. With the bathtub open, I'm going to go ahead and open up this valve and just drop the water level inside the tank a little bit. You can tell that's kind of nasty water. We have very hard water out here, so there's actually a lot of sediment that builds up in the bottom of the tank. I cleaned that out when I changed the heating elements about a year ago, but it looks like it's kind of clogged up some more. Opening that bottom drain valve allows the hoses to drain out, and just to make sure the water level is below the top of the tank. That way when I take this valve out, shouldn't have any water come out. Next is probably going to be the hardest part of the job, and that is loosening the valve. I have a large crescent wrench here, and if that doesn't work, I have an even larger pipe wrench, and we'll see what it's going to take to get it apart. Now the temptation is, because it's accessible on this side, is to put the crescent wrench here, but you actually have the risk of breaking this and crushing it, which won't help anything. And then the better option is to get it from behind and get it sized so where it'll fit on there. And that makes sure that you're not going to crush or damage this, just in case you run into problems and you can't get it off today. Okay, we're all on here. I'm going to see if I can do this one-handed. Oh, wow. Actually having that putty or tape on there, that Teflon tape, really made it easy. It loosened nice and easy. So that is a blessing. And hopefully when you loosen yours, it will come loose as easy as that one did. Okay, so I should be able to just loosen it by hand now. Now do beware that in this case, I just shut this hot water heater off, and so the water inside is going to be hot. And so that's why you want to make sure it's depressurized, and that if you can drain it down a little bit, that will be the safest way to do it, because there is going to be hot water in here, and depending on how high you set it, it is a burn hazard. So you just want to be careful with the hot water. All right, there we go. And that's it. It actually doesn't look as bad as I thought it would. One interesting factoid, I have the new one here, and when I was reading through and looking at the label, it is exactly the same. And so even after 30 years, even the graphic on the back of the two is exactly the same. So this is an old, I'm sure this was written by some safety commission and mandated by the government. And so everybody puts this on their valves no matter who the manufacturer is. Because this is an this one is A.O. Smith, and this one is from Richmond. The new temperature and pressure relief valve already comes with sealant on it, so I don't need to add Teflon tape. It's just a matter of putting it in and installing it. You want to be careful, no debris has fallen in there that could cause a cross-threading situation. Now, in case you're wondering how much to tighten this, all I can say is to go by feel. You're going to know when it's getting tight, you know you have less than a full turn left. And so as you tighten it down, it's going to go smooth, and then it's going to start getting pretty tight. And that's when I would say go ahead and get it whatever direction you want this to face. When it is set, you want to get it in that position. You don't ever want to loosen it back up, because that could cause a leak. And so decide ahead of time. If you want it facing coming out this way, then that's where you stop. In this case, I want it facing coming out this way because I want to avoid the electrical panels below. Just as an extra safety measure, not have the pipe run in front of that, because when I want to change the temperature of the upper and lower heating element, I don't want that pipe in front of it. And so I have it running just to the left of those openings in the front of my tank. Now that I have the temperature and pressure relief valve tightened up, I'm going to install the drain tube, or what they call the runoff tube. Now this runoff pipe is a little bit long, so before I can install it, I'm going to need to cut it to length. To know how long it should be, I'm going to go ahead and take this tape measure, and it's just going to be an estimate. Bring it out here, put a little bend in it, take it down to the place I want to cut it off, and in this case, it's going to be about 50 inches long. The first step of this installation is pretty simple because it's just hand tightened. You don't need any Teflon tape, any sealant. I mean, this is something just to direct the hot water when that valve happens to pop off every once in a while. Now this valve, when it does overpressurize or overheat, it'll pop off for just like a second or two. And so it's not a lot of water pouring out of there. When these fail, they fail like you just saw. They'll either start, the spring will get weak and they'll start popping off with less pressure, but they'll go ahead and close back up, or they're going to start seeping. And so when we bend this, I'm going to direct it down into like a little trash can or bucket or something like that. Some people will direct it down into a crawl space. I don't want to drill a hole in the floor just because that's an opportunity for mice to get in this old house. And so I'm going to direct it into something. That way, every once in a while, you just glance down in the bucket or trash can. If you see some water in there, you know there's been some activity in this valve. And so on your annual basis, when you open this and close it manually, it'll just go in that bucket and then you can empty it. The next step after I hand tighten this is I'm going to need to bend this tube because I bought the straight one. You can buy them pre-bent, but I don't know if you can see, this is kind of a tight area. There's no way for me to take one of these with a 90-degree bend in it and thread it in. So I had to buy the straight one, and then I'm just going to bend it myself. Now the other option you have is to basically piecemeal this together. Buy this piece and then have it to where you can connect a piece of regular PVC to it, then put an elbow in it, another piece of PVC in it. For me, I just wanted the simplicity of this installation, and so this is something I'll just hand tighten, and really that's about it. And now I'm going to go ahead and heat this up, and I'll show you how to do that. There are some great YouTube videos out there on how to heat regular PVC. Didn't see any on the thin wall PVC like this, but they involve heating sand on a stovetop and then filling the pipe with sand. It's probably the best way that I saw to do it because it maintains the shape. Using a heat gun is another one, but for this thin wall, I'm concerned that a heat gun actually could melt it or burn holes in it, and I definitely don't want to do that. It's just maybe overkill for this particular job. With the regular thickness walled PVC, I think the heat gun also could be a good choice. You just have to be careful to not overheat it, and you want to heat it evenly. So in this case, I'm actually just going to use a regular old hair dryer. I'm going to turn on the high heat setting and the low blower setting. So that's going to give the maximum amount of heat, because when you have high blower, is actually going to move air over the heating element faster, and it's not going to be as hot coming out. So we're going to try that and see how long it takes. Well, that's 10 minutes of my life that I'll never get back. So I would not advise using a hair dryer. Maybe if you have one that's a professional or high heat hair dryer, that might work. But since I don't have a heat gun available to me, I'm going to try plan B. Plan B is that I have boiled some water in this tea kettle, and so I am going to pour it into the pipe. Now, do this at your own risk. I am not liable for you being stupid and burning yourself. I'm only liable for me being stupid and burning myself. So I'm going to very carefully fill this boiling water into the pipe, let it heat, because this thin wall, it should heat pretty quickly, and hopefully that will make it soft enough that I can make a nice 90-degree bend. All right, water is boiling. I'm going to lift up the end of the pipe. I do have a protective glove on. And I'm going to lift up the end of the pipe and very carefully pour the water in, and it should start getting soft pretty quick. It's softened, but it doesn't really feel like it's going to be very malleable. I think I'm going to heat some more water. All right, here's the second batch of boiling water going inside. Well, I think that's going to be about as soft as it's going to get. So I'm going to drain the water out and quickly try to get this into a nice radius going down. Shit. Fucking work. Well, I am on to plan C now, and that is to take the piece that I cut off and bend it in a 90-degree, and then heat it up on the ends to be able to open it up a little bit and slip it onto that pipe. Well, it is ugly, but this thin wall is really hard to deal with. You know, when you're dealing with regular PVC for pressure pipe, that thicker wall really helps with stability. I did the best I could to heat this evenly, and it's ugly, but the main thing is just to be able to get it to let the pressure out in short bursts. And so this pipe remains open, so I don't think that's going to be a big problem. It's ugly. I apologize to all of you. There are going to be better ways, and hopefully you don't have this type of a setup where you have to install the pipe before. And then I went ahead and heated up the end, and you can see I'm letting it cool right now. And I actually used the end of a rolling pin, the rolling pin handle, to open this a little bit, and then while it was hot I ran in here and pressed it onto this. And so once it's cool, then I'm going to pop it off and do the other end. And then if you want to make sure this stays together, even though it's really tight right now, but when that pressure it could blow off, you can put some PVC glue on there, and that'll guarantee that it will hold together. Now that this is cooled off, I have these ends stretched out to where they'll slip on the pipe. I'm going to go ahead and cut this to length and install the elbow. Let's go ahead and pull this label off so that doesn't interfere with the glue. Okay, got that. I'm heating this one a little bit too much, but this should slip right on. There we go. Wow, that's really tight. I'm going to go ahead and glue this when this is all fit together. but that does fit. The nice thing when you stretch something like this, it just fits so nice and tight. Next, I'm going to cut this to length. It's kind of, the water softened it, so it made it kind of wobbly. I'm going to go ahead and keep this end, and so I'm going to need to shorten it about that much. Now we can slip this together, make sure everything fits fine before I put the glue on. Yep, nice and tight. I hope this video was helpful. Even though that elbow turned out butt ugly, at least it saved me a couple $100 versus calling out a plumber, and hopefully it'll save you some money too. Have a great day.